Hello everyone, and welcome back to the Pondering Philomath. In today's video, I will be introducing some of the fundamentals of trigonometry, namely the sine, cosine, and the tangent functions. In a right-angled triangle, the three sides have special names assigned to them, and the first step in calculating the sine, cosine, and tangent is to correctly assign these names to the given triangle. Now, these three names are the hypotenuse side, the opposite side, and the adjacent side. So how do we notice which side is which one? Well, the very first step here is to find the right angle, which is over here in this case. And the side in front of the right angle is called the hypotenuse, right? So right opposite to the right angle, we have the hypotenuse, always. And in a right angle triangle, the hypotenuse is the longest side of all of the three sides of the triangle. Now, the other two sides depend on which angle we have. So if we have an angle given over here at the bottom, then we look at the side which is opposite to it, so the side which is not touching the angle, right? The only two sides which are touching this angle is this one, right? So here's the angle, and this side is touching it, and this side is touching it, but this side is not touching it. So this is the opposite side. Or another way to look at it is the adjacent side is the side which is touching the angle but is not the hypotenuse, right? So we have the hypotenuse over here, which we defined first, and then we can say, okay, well, the other side then has to be the adjacent, right? So this is how we define the hypotenuse, the opposite side, and the adjacent side. And this is really the first step that you need to do with any right angle triangle. Now, once we have done this, we can then move on to calculate the sine, cosine, and the tangent of an angle. And the most common way of learning the trigonometric equations, and I'm sure you must have come across this one, is the SOH CAH TOA. Right here, right? And this basically defines the three trigonometric equations, which we will be learning about today. But if this one is not really helpful for you, then there are some other mnemonics. For example, some of our children are having trouble over algebra, or some other gruesome ones like she offered her cat a heaping teaspoon of acid. Now, if this is your liking, then choose your picking, but better still, have a go at making one of your own. But for this video, I will continue with the SOH CAH TOA. So, now I would like to move on and show you how we can use these three equations in two applications. Right, so the first application is finding the length of a side in a right angle triangle. So we're given a triangle over here, and we have to find this side over here, and let's just call it B. And the first step is defining the sides of the triangle, right? So we find the 90 degrees in our triangle, which is over here, and we can see that the opposite side to it is our hypotenuse, right? This is the longest side of all of the triangles. Right, so we just label it H, and as this angle is given, we know that the other side touching this angle is going to be our adjacent side, so we'll label that A. And the other remaining side is our opposite side, which is directly in front of our angle. So once we have defined this, we can then write down the sides which are relevant to us, right? And so which sides are those? Well, we have to find the opposite side, right? We have to find B, and B is opposite to our angle, and this is our angle. So we just write down the O, because this is relevant. And we see that our hypotenuse is given, so we have a value for the hypotenuse, so that is going to be relevant as well. And we see that we can just ignore the A because we don't really need it, right? So we'll just leave it out. So these are the two relevant sides that we have in this triangle. So then we look back at the SOH CAH TOA, and we see, well, O and H, that's matching over here, so we'll have to use the first equation, the SOH. So we'll just quickly write it down, and that will be sine of an angle, and that angle in this case is 46 degrees, is opposite over hypotenuse. The opposite in our case, the O, is the B, right, which we have to find out, and the hypotenuse is 110. We'll just quickly rearrange it for b, and we'll just multiply both of the sides by 110. And then we have 110 times sine of 46 degrees is equal to b. Right, now let's take a calculator. And we have 110 times the sine of 46 degrees. And so our b, if we round the figure off, we get 79. So this is our b, right? And be careful to set your calculator to degrees and not radians. Otherwise, you'll get a different value here. So this was the first application, right? And this is to find the length of a side in a right-angled triangle. And here you can notice that we cannot use the Pythagoras theorem over here, because in order to use the Pythagoras theorem to find the length of a side in a right-angled triangle, we need to have two sides already given. But in this case, we don't have two sides given. We only have one side given, right? So that is why we have to use this, because we have one side and one angle given in a right-angled triangle. Now, the other application that we have is finding an unknown angle when we're given two sides. So here we're given this side and this side. And how do we solve this problem? Well, again, we use the same method. We have an angle, and the first step we do is we define or we label all of the sides. So again, we start with our 90 degrees. We have the 90 degree over here, and the side in front of it is going to be our hypotenuse. Now, this is the relevant angle. One side which is touching the angle is the hypotenuse. The other side which is touching the angle is our adjacent, and the other side is our opposite. Now we look for the relevant sides that we have. The first relevant side, which we're given the value of, is A, so the adjacent side, and the other relevant side, which we're given, is O. So we see that we don't really need H, right? So it's not useful. So again, then we go up to our SOH CAH TOA, and we see, well, the O and A is present over here in the third equation. So then we can use the third equation, that is tangent of D is equal to opposite over adjacent. And the opposite in our case is, the O is over here, so we have 7. And the adjacent is 4, so we have this, right? But we're still not done, because we have to find the angle D, right? And what we do over here is we use the inverse of the tangent to get rid of the tangent here, right? So basically, if we have to get rid of a multiplication, for example, 3 times A is equal to 21, for example, and we wanted to get rid of the 3, and this is a multiplication, then what do? We divide by 3 on both sides. And the division is basically the inverse of a multiplication. And then we would have A is equal to 7, right? So the same principle we are using over here, and tan inverse is the inverse of tangent. So that gets rid of the tangent, and then we have tan inverse of 7 over 4 over here. And we use the calculator, so tan inverse of 7 divided by 4 is going to be, tan inverse of 7 over 4, that is 60.3 degrees. So D is going to be 60.3 degrees. And that's it. So I hope you understood the methodology of how to find the markings for all the sides of a triangle, and as well as how to use these three equations in these two applications. So don't forget to like, share, and subscribe the video, and tune in for more such videos on the channel.